Probability. Let's take a deeper look by first looking at probability scales. Now, if I said, are you 100% sure? We know that means absolute certainty. So 100% means certainty. 0% means impossible. There's no chance it can happen. 50% is, well, 50-50, right? Now the question is, how do we convert percentages to decimals? Percent, meaning per 100, to convert from percentages to decimals, you just divide by 100. So if we were to convert this to a probability scale, we just divide all of these by 100. So in probabilities, certainty is 1. 50-50, if we divide that by 100, is 0.5. And 0 is still 0. Now, let's look at a proper probability scale and look at some examples. So, on this probability scale, I want you to place A, B, C, and D on one of these numbers. For example, I'll do the first one. Landing tails on a fair coin. Well, a coin only has two faces, tails and heads. So, it's 50-50, which means it would be number 5. This is where A would go. Where would B and C go? B, spending money in your lifetime. I would say that's a certainty. You're definitely going to spend at least a penny in your lifetime. C, surviving on the moon without oxygen. I don't know about you guys, but, without oxygen, don't think you're surviving. This is a clear, impossible situation. Now, I want you guys to tell me in the comments, where would you place D? Rolling a prime number on a fair die. Now, guys, when I say die, don't mean someone dying. Die is the singular of dice. You all know what dice are. Die means one of them. So, in the comments, where would you place it? Between 0 and 10. Now let's look at our theoretical probability formula. So the probability of any event equals the number of favorable outcomes, so the outcomes you're interested in, divided by the total number of outcomes. Let's look at a coin. We use the example of tails and heads. And I said, what's the probability of tails? We said 50-50, right? Because the probability of tails is our fraction. On the numerator, how many favorable outcomes are there? Well, I want tails. There's only one favorable outcome. And we divide it by how many outcomes are there possibly? 1, 2. Half. The probability of landing tails is 1/2, which if you convert to a decimal is 0.5, which is 50%, 50-50. Let's look at another example. Next example, what's the probability of choosing a king in a deck of cards? Now, if you look at the graphic, here is a full set of cards. There's 52 cards. So my total number of outcomes is 52. And then if you were to count how many kings are there, well, there's hearts, clubs, spades, and diamonds. There's 4 kings that are favorable to us. Now, we could leave our answer like this, but you should notice that we can simplify our fraction by dividing top and bottom by 4, which leaves us with 1/13. Now, there's a quicker way you could have seen this. For every single suit, there is 13 cards. One of those has to be a king. So, we could have said, for every suit, there's 13 cards. One of those is favorable to us. And because for every single suit, the ratio is maintained, 1/13 is also the same no matter which suit you talk about. Now, let's take a look at sample space tables. Sample space tables help us visualize all possible outcomes. For example, I roll 2 dice this time, not die. So I roll 2 dice and add the 2 numbers on the upper face. Show all possible outcomes on a sample space table. So my sample space table may look something like this. I'm adding the 2 numbers on the upper face of each dice. each die will go from 1 to 6. So, here are my outcomes for die 1. Here are my outcomes for die 2. I'm not talking about the Die Hard movies here. And what we're going to do is we're going to add up my outcomes. So if die 1 has 1 and die 2 has outcome 1, we're going to add them, make 2, 1 plus 2, 3, and now let's fill out the whole table. So guys, these are all my possible outcomes from throwing 2 die and adding the numbers on the upper face. Part B says, find the probability of getting a total of 3. What's the probability of getting a 3? Remember, I said division, and we're saying, what is our total number of outcomes? Now, my total number of outcomes is everything here. How many numbers do you see here? Well, you can quickly do it by saying it's a 6 by 6. There's 36 possible outcomes. Which one of those are favorable to us? Well, we're looking for the number 3. Where do you see the number 3? Here and here. There's 2 outcomes that are favorable to us. And now what we're going to do is simplify. We can divide top and bottom by 2, and we get 1 over 18. And that, guys, is sample space tables. The last thing I want to cover is theoretical versus experimental probabilities. Now, theoretical probabilities is what we've been doing so far. We know the underlying probability of an event. For example, at the beginning, when we looked at landing a tails, we said it was a half. Now, in reality, it may not be the case. If you were to go and toss a coin, you're not necessarily going to land tails half the time, which takes us to the experimental probability. Now, this is the probability based on observing the favorable event in an experiment. So, let's take an example with tails and heads. So, take a look at this example. I threw a coin 100 times, and here were my results. I got 30 tails and 70 heads. What's the experimental probability of landing tails then? Experimental probability meaning, from my experiment, what is the probability of landing tails? Well, I got 30 out of a total of 100 throws. And guys, we can simplify this by dividing top and bottom by 10 or crossing off a 0, 3/10. The theoretical probability here is 1/2. And a very regular question that gets asked is, how can you get this experimental probability closer to the theoretical probability? What do you guys think the answer is? The answer is you need to increase the number of trials. If you did this 1,000 times, this may get closer to 1/2. And we have a strategy of checking this. It's known as chi-squared test, which is a much more formal, and it's something that you learn at a very high level of mathematics. And we can check using hypothesis tests to see if this coin is actually biased. But in general, guys, the experimental probability should get closer to the theoretical if this situation is fair, if you have a larger number of trials. Finally, where are probabilities used? Well, guys, probabilities are all around us. One of the most interesting places, I think, is in quantum mechanics and Born's law. Born's law is a probability of finding the general location of a particle at any given moment. Because if you're trying to locate an electron, we can't actually determine its exact position, but we can calculate the probability of it being in a general area. Another place we can use probabilities is in weather forecasting. No weather forecaster can tell you exactly what the weather's going to be like tomorrow. It's all based on probabilities. Other places which are quite cool, I think, is in poker. If you've watched any poker on YouTube or anything, they always have percentages in the corner. And these are going to be calculated by the players for them to calculate what their expected value is for playing certain hands at the turn, the flop, and the river, etc. They want to know, and they want to try and extract as much value as possible in the long run. Also, in blackjack, some individuals do count cards. Maybe you've seen the movie Rain Man, and casinos can avoid this by playing with multiple decks. Probability is all over the place. I could name countless things. Guys, if you enjoyed this long form content, I'd really appreciate it if you hit the like button and drop a comment down below. And follow me for more content like this.